So now we're going to move to this other section, and I'm sure everyone's kind of tired, but we're just going to plow on, and I'm going to give a talk. I'll do it quite quickly so as not to fatigue you too much, and then Geoffrey will make some remarks as well, give a short talk, and then we're moving to the magic. So the reason to stay is not because of this, but because of the magic at the end, which is going to be kind of extraordinary. So let me just share my screen. Let's just jump right in. Most people here are familiar with the idea of what happens when matter and antimatter come into contact. You get mutual annihilation. And I'm going to talk about this current crisis in terms of two hidden worlds coming into collision: the world of microbes and the world of hyperobjects. Okay, so microbes were essentially discovered in the 17th century with the appearance of light microscopy. And it wasn't until the end of the 19th, with the work of Koch and others, that we understood that microbes were actually vectors for disease. So this is the invisible world that we're talking a lot about these days. There's another invisible world, and this is the world of hyperobjects. This is a term from the philosopher of the environment, Timothy Morton. And this is invisible by virtue of its enormous size. And Morton was interested in trying to give us intuitions for understanding things that we wouldn't have a sympathy for because we couldn't see them, like the environment. The example he gives in his book is the difference between 1 or 2 polystyrene cups and all polystyrene ever synthesized. And I think to understand what happens when these two invisible worlds collide, you need mental upgrades. Now, yesterday, Gillian talked about humans being hardwired for narrative. I think that's completely false. I don't think humans are hardwired for anything. At best, we're soft-wired. And it's the fact that we're soft-wired that makes education possible, right? If we were hardwired, there'd be absolutely no point of going to school or learning anything. So, but that's a debate I should have with her. And I'll introduce these mental upgrades in 3 different concepts: the idea of a complexity crisis, the idea of critical systems that we've talked about quite a bit, and some new idea I'm playing with, which I call complexity claustrophobia. So in a recent paper, Geoff West and I argued that we're experiencing something unique in human history. And the thing we're experiencing uniquely is a complexity crisis. And that is the collapse or near collapse of multiple coupled complex systems, not just one or the other. So let me just give you some data to make that point clearer. Everyone knows this slide. This is a slide of time in months in the year 2020 against incident of COVID infection and the S&P 500 index. And you can see very early in the year, they were strongly negatively coupled. An increase in COVID infection led to a concomitant reduction in the value of the market. But something interesting happened late in the year. They became somewhat decoupled. And if anything, maybe they're even negatively correlated now. And it's not just markets, it's also human beings, in the sense that there was a recent paper published on 6,000 companies, small companies, where the average number of layoffs was about 40%. So this is real lives. Here's another set of correlations which shows the compositional heterogeneity of the effect. So this is the capital asset pricing model. And here you can see some trends are positively correlated, in this case, utilities, healthcare, and telecom, whereas others, energy, transportation, the automobile sector, negatively correlated. And all of us are familiar with the final one because of the effect of COVID on our social lives, a huge reduction in the ability to go out and socialize, in this particular case, reduction in ability to go to restaurants. So all of these systems have been perturbed by COVID. Let's look back to 1918, and this gets to a point that David made. This is what happened to the Dow Jones Industrial Average with the Great Flu of 1918, which killed vastly more people and infected a third of the planet. Basically nothing. It's interesting that in this paper, there's a trend line that's been put in that says minus 10% at the highest peak. No one in our community would have drawn that line. it's not above the stochastic null expectation. I think it was drawn there because they wanted there to be an effect felt by the market. And if you look at more contemporary epidemics, it's even worse. If I were to ask you, what is the impact of an epidemic, in this case on stock performance, you'd probably say it's positive. In other words, all of those black points seem to occur prior to an increase in value, not a decline. So this is when we say complexity crisis, what we mean is that historically, a perturbation such as COVID has been largely invisible. Whereas in all of these indicators today, you have all of these positive and negative correlations emerging. And the question is why? So I now want to talk about criticality. This is a famous model. It's not the one that I work on, but it's known as the model of self-organized criticality, or the sand pile model. If you were to drop grains of sand onto the ground, you would build up a sand pile. And eventually you'd hit a critical slope where you'd find avalanches of sand falling down the sides. And what happens in this model is that by virtue of these avalanches falling, you flatten the slope, you move back to the non-critical state until you build up enough sand to reach the critical state where you find avalanches appear again. This is called self-organized criticality because it's a slowly driven, non-linear dynamical system that tunes to a critical point. And at that critical point, you see avalanches that have a characteristic parallel distribution, some very large and some relatively small. So over the course of SFI's history, a number of us have been interested in the following question. Do all complex systems, things much more complex than sand piles, exhibit criticality? And on the left is a well-known paper by our colleague Ricard Solé with Per Back on ecological systems. Here's one by John Rundle, I think is on the line today, a review of critical systems, and a couple of our papers recently on conflict. And all of these papers collectively suggest that adaptive systems tend to be tuned to near critical points where they'll manifest this avalanche-like behavior. And this gets to the second point that I really want to make clearly, the difference between a critical perturbation and a critical system. There's nothing special about a sand grain, right? What's special is the disposition of the sand pile, the critical system. And if you drop a sand grain at the critical point, there's the possibility of eliciting an avalanche. The same is true of COVID. There's been a huge amount of focus on the virus, that is the critical perturbation, but much less attention paid to the critical system that exists independently of the virus and will exist when the virus goes away and be susceptible to perturbations into the future. Here's a nice example, the so-called football war between El Salvador and Honduras, where people say a football game that was a World Cup game where Honduras won 1-0 led to a war. But of course, it wasn't the football that led to the war. It was the pre-existing patterns of immigration and tensions around that that led to a national state that could be set on fire by something as trivial as scoring a goal, or not as trivial, I don't know, maybe that's not trivial. And finally, a bullet. This is, of course, the famous case of the assassination of Archduke Ferdinand. Of course, it wasn't the assassination, right? It was the growing nationalism, imperialism, and the alliance between nations that led to a domino effect. So the critical perturbation might have been the shot, but if you really wanted to understand what was going to happen, you'd have to study the critical system. And I think much of our discussion is centered on critical perturbations and has to shift towards studying whether or not the systems we care about and live in are near critical, because, you know, if you have a house of cards, even a flea landing on it will knock it over. So that's the second point. The third point I just mentioned, sort of slightly flip, is this notion of claustrophobia. It's something we're all experiencing a little, locked up. And where does that come from? Well, it was first used by Benjamin Ball, where he defined claustrophobia as the fear of enclosed spaces. It was just a definition with no cause Freud made an effort to explain where it came from. And Freud suggested that we have some anxiety, some fear, that moves along some pattern of associations that finally ends up projected onto some object, which he called the phobic object, which in this case was the enclosed space. So we have an anxiety associated with some pattern in the world. It moves through associations to become projected on the space. And I want to claim that in 2020, we're suffering from complexity claustrophobia. The anxiety in this case is our uncertainty and incomprehension of the complex world. The associative path leads it to be projected onto a phobic object, which in this case, the enclosed space, is the intervention. And let me give you some examples. Anti-vaxxers, right? This fear of the vaccine. The idea that the mask, which prevents transmission, is a muzzle of free speech. The idea that CO2 is not a pollutant and a cause of climate change. What's going on here? I actually don't think, and it gets to Matt Jackson's earlier point about feeding people more data to cause them to change their minds. I think it's because they're suffering from complexity claustrophobia. I think people are living in a world that they very poorly understand. And what they then do is project their anxieties onto the interventions that other people might or might not understand. Typically, the reason why people feel this way is explained in terms of what I would call microbial explanations. They're highly reductive. This is a recent paper, relatively recent, on the science of why we don't believe in science. It's a review of many different positions, including Jonathan Haidt's and many others. And what you find is all of these papers explain this claustrophobia or anxiety in terms of psychological disposition. It's completely reductive. I think the real answer lies at the level of the hyperobject itself. And we need to shift towards what I'm going to call hyperobjective explanations, meaning an understanding of how the complex world works. Because if we don't do that, you don't deal with the primary cause, that is the anxiety of uncertainty. So that's the sort of final point. And I'll end with that. And I'll just turn it over to Jeff and just say that I would argue that one of the best examples of one of these hyperobjects is the city, something that we live in and depend on, but very poorly comprehend. So, Geoffrey, are you ready to go?
David had, on the program, it says there's going to be a discussion between David and myself. That's what I was sort of prepared to do. And then David told me a couple of days ago he thought that would be boring, which is probably right, and that we should each give a little presentation. So I put together something based on something I've already done. And so some of you will be bored stiff by seeing a repetition, but it is a little bit different. And
I see 65 slides there, Geoffrey.
Yes, no, they're not going to be. I'm just going to do a sampling here. So what I want to talk about is very much a big picture view of thinking about some of the questions that we have to face on the planet. And I will talk a little bit about COVID and the pandemic. But I want to get to the whole question of not just addressing the questions, but the idea that we need to understand the underlying dynamic, and that's what I want to scratch the surface of. And David gave the segue by talking about cities, and I'm going to use that as a focus of attention to talk about some of these questions. And I want to remind you by showing you an imagined photograph taken in the year I was born, 1940, at night by a NASA satellite of the Earth, and compare it to what it looks like today, and it's quite extraordinary. The Earth is aglow, it is literally on fire, and we all know what this represents. It does in fact represent the extraordinary amount of urbanization that's taken place, and that reflects of itself the huge growth in population and socioeconomic activity. And just to put some framework on that, that's the way I should be thinking about our problems in these terms. And just to remind you that we are urbanizing, roughly speaking, at about 1.5 million people every week, which means by mid to late century, most people will be living in cities. Already most are in developed and developing countries. And indeed, from that viewpoint, we are in fact the pandemic. And just to remind you, the pandemic is derived from pan and demos, from Greek pandemos, all the people, and all the people are effectively and certainly will be living in cities. And I also remind you, did I hear something? Did I do something? Anyway, city, remember the Greek for city is polis, and many of the things that are implied in what we've been talking about are also associated with that: policy, politics, police, etc. So city, here it is. This is what we usually think of. It's infrastructure, the buildings, the roads, the electrical lines, and so on. But the important part of a city, of course, is the fact that this is actually a stage. This is a machine for facilitating social interaction and creating social networks in order to facilitate ideas, innovation, wealth creation, entrepreneurship, and so on. And great cities, of course, provide formal institutions for doing that, but also informal ones, such as we see here. And so we can think of the city as, just to repeat, as this extraordinary machine we have for creating wealth, knowledge, innovation, and ideas in order to increase the standards and quality of life of all its citizens. And to a large degree, in that respect, it has been enormously successful, but it has become at a huge cost. And that cost is, and I'm inspired by the second law of thermodynamics, already touched upon earlier, namely that inevitably this has created social and physical entropy, all the things you're familiar with, and all the problems we have to face in terms of what's going on in the planet. It's produced pollution, affected the environment, created climate change, increased crime, greater inequality. It's created more disease, indeed pandemics, and social unrest. And indeed, the way we've dealt with those problems traditionally is, this is just some arbitrary list, we put boxes around the various categories of the problems. But in fact, what we do is we put boxes within those boxes and boxes within those boxes, and gradually, at a finer granularity, deconstruct the system into its small components in space and time. And I would say, to a large degree, that's been remarkably successful, but it misses something truly essential and what SFI is all about and what this symposium is all about, namely that you neglect the fact that all of these are interdependent and are interconnected. And you, by neglecting that and not thinking more systemically, you do so at your peril, because each one is a complex adaptive system, and the whole is a complex adaptive system of complex adaptive systems. And by neglecting it, you have all kinds of unintended consequences. Here's a little cartoon. Can't wait for the pandemic to end. And of course, it's back to normal if you only focus on the pandemic. So this has already been said. I'm not going to say it. It was, David just showed it, that of course we should not have been surprised that within this framework, that a mutation of a virus in a far-off city in China results in all these multiple things happening in different parts of the world that have been seemingly disconnected, because they are, of course, connected. And indeed, this is the mother of all butterfly effects, because a small perturbation somewhere has in fact induced all kinds of effects elsewhere, even at an exponential rate and at an exponential effect. So I want to talk in very general terms, and I'm going to simplify everything tremendously, so please excuse me in the short period of time. But so cities, like all complex systems, are really the interface, integration, and tension between, on one hand, their physicality, their energy, resources, metabolism, infrastructure, and the exchange of information in their social networks, in this particular case, which creates innovation and all things I talked about earlier. And all of that happens through networks, ones you're familiar with, transport networks and resource networks. And here's a cute one. This is the network of the traffic flow into and out of Laredo, Texas, of all trucks during 1 year. And what you see is a beautiful hierarchical network. And indeed, it doesn't take much imagination to realize that it looks just like what's keeping you alive at this very moment. It is, in fact, quite similar. The only difference being this is two-dimensional and this is three-dimensional. and indeed all life functions by the flow of information and energy and resources through networks. Is your brain, white to gray matter in your brain, and so on. And one of the extraordinary things is that the constraints of these networks mathematically lead to these remarkable scaling laws. And namely, here we have a complex adaptive system with that's evolved by historical contingency. And yet, if you put the constraints of the network on, it says that all these things, if you look at them in the scaling phenomenon, line up on a straight line. Here's the most famous one in biology: metabolic rate, Kleiber's law versus size, plotted logarithmically, going up by factors of 10. And all these animals lie on the same straight line. And this straight line has another important property, and that is it expresses an economy of scale because the slope of this line is less than 1, sublinear, which means the bigger you are, the less energy is needed to support the same gram of tissue. So bigger in that sense is better, is more efficient, and so on. And the question is, are such hidden laws of biology, and they do stretch across the whole entire spectrum of biology, do they have a reflection in social organizations, whether cities, companies, economies, and so on? So here's some very mundane data on gas stations versus population size plotted in the same way. And what you see is something extraordinarily similar. We see that they scale. There's an economy of scale because the slope is less than 1. Here, instead of being a slope of 3/4, as we saw in biology, it's about 0.85. But otherwise, in character, it's similar, but it's also similar in its universality because this is true of all infrastructure. That is, if you look at buildings, roads, gas stations, as is here, electrical lines and so on, they all have the same character. And even so, it's true across not just 4 European nations, but across all European nations, Latin America, China, Japan, Americas, and so on. But this is sort of the uninteresting part of cities from this viewpoint, because the whole point of cities is something that's already been touched upon, is that they are to support social networks. And here's a classic picture of a social network. But it's a very misleading one. It's one we always show, but it's very misleading because a crucial point about a social network is not just the interaction and exchange of information, but it necessarily has to be tied to place, and it has to move between places. That is, it has to be tied to a 2-dimensional surface. That is what the city is in a certain sense. And so this is the phenomenon that's going on. It's that picture in the middle is the interface of all these things. And what is going on there is A is talking to B, who's talking to C, who's talking to A. And in that conversation, there is continuous positive feedback mechanism. Ideas are being produced continuously, almost all of which are pointless, useless, except possibly to the people there. But amazingly, this dynamic is the one fundamentally that eventually and sometimes produces quantum mechanics or the internet, or a Google, or an Amazon, or a Santa Fe Institute. And so this positive feedback is fundamental, and this also has something that we don't see in biology. It gives rise, instead of to an economy of scale, it gives rise to something we call superlinear scaling. That is, instead of the bigger you are, the less per capita, the bigger you are, the more per capita. And at the same time, it speeds everything up, in contrast to biology, which as you get bigger, everything slows down. Here, the network, that positive feedback inherent in network dynamics, social network dynamics, increases inextricably the pace of life. And here's data. This is a panel of just 6 arbitrary metrics. I could show you lots of other data, but there's different metrics in different countries. Everything from wages and GDP, patents, ideas being created, to restaurants and crime and so on. And what you see is something really amazing. This is just the data that they're all the same. They all have the same slope, and that slope is, roughly speaking, 1.15. That's the superlinear behavior. And you can see that in that sense, that the similarity indicating the interconnectedness of all these things, even though they may apparently be different, because they all derive from underlying social networks and they have a universality. So here's what it says in English. If you double the size of a city, in an urban system, then you save about 15% on all infrastructure, and at the same time, you gain 15% on all the good things, income, wealth, ideas, education, and so on, but also all the bad things like crime and disease and COVID-19, all by about 15%. And you can check on that by examining billions and billions of data from mobile phone connections to measure social connectivity. And indeed, what you see is that social connectivity is sort of predicted in a sense by this idea, this conceptual framework, has that same 15% additional sort of value added the bigger you are. And one of the big questions is, if we continue in this soulless, inhumane way of interacting via pictures like this, so I'm here talking to the walls and this screen without seeing any of you, how does this change things? Because I no longer need to be tied to place. In fact, I'm mourning the fact that here we are, one of our great events at SFI with all these lovely people that I've seen on the screen two-dimensionally, but I can't smell them, touch them, even kiss them in some cases. And how is that going to affect all of this? So I want to, in the last remaining minutes, just tell you a few things of consequences of this. So I want to talk briefly about the spread and transmission of not just viruses, but also ideas and innovation, because it's sort of similar. It all goes through human interactions, it goes through networks, and experts will have to really forgive me for boiling it down to just its essential features. I'm not going to write any equations, but the rate at which ideas of viruses spread clearly is equal to whatever the transmission rate is within the social network between people, but corrected by the recovery rate, if it's a virus recovering from COVID, or a rejection rate if it's an idea. I don't believe that the state should support health, or I do believe that we should make America great again, whatever. There's a rejection rate, so there's a simple equation one can write down, and that equation actually is the fundamentals of all transmission. And this is what Lauren talked about yesterday, and that gets down into the nitty-gritty of all that. Here I'm keeping it, as I said, at this very coarse-grained level. But roughly speaking, built into this, if you solve the equations, is that you either have exponential growth or contraction. Some other things, but these are the two important points I want to emphasize. And obviously you have growth if the transmission rate is bigger than the recovery rate, and contraction if the rejection rate is bigger than the transmission rate. And actually this is pretty much mathematically equivalent to the mythical statements about R0 being greater or less than 1. That's basically the two cases. And the important thing is it's exponential, so it has tremendous sensitivity to how you change things, but you can change. What this tells you is the obvious thing, that you can change how quickly ideas are transmitted, or how quickly viruses change by manipulating these networks. And so if you talk about viruses, you need to decrease transmission rate and increase recovery rate, and that's what we're trying to do. That's what should be done. We do it by physical distancing and in masks and so on. And we do the recovery rate, of course, by having a serious health system, and we develop vaccines. So that's in terms of disease. But in terms of ideas, we have exactly the opposite. We want to increase the transmission rate and decrease the rejection rate. And we do that by increasing social closeness. Whether that needs to be physical closeness is left for debate. But you also need to decrease the rejection rate by having discussions, meetings, propaganda, fake news, real news, and so on. And all of this, just I want to emphasize, is sensitive to exponentially sensitive, which makes it extraordinarily difficult to control. So you're familiar with this, and David showed a version of this. This is mobile phone data showing the decrease in connectivity early on in the pandemic, and leading, of course, to the flattening of the curve. This is just, you're familiar with this. But here's the point, 2 points I want to make that I'm getting to. First, this whole theoretical framework gives rise to the total number of infections increases more than linearly, superlinearly, in the way I described, with whatever the population of the network is, and the rate at which it does it increases faster with the increasing population. Consequently, if you have a network with a larger population, whether it's a bigger city, a bigger country, a bigger corporation, a bigger group that forms a network, then they will have obviously more cases, but they'll have more cases per capita, but also they would generate more ideas per capita. And you saw that where I showed you pattern data later on, and they do it at a fast.
Is it only me who doesn't see Geoffrey?
No, I think Geoffrey may have frozen here.
These two are at odds. And these are the things we were just discussing in the last wonderful session. All these various things come into play. It's not just the integration of the economics with the epidemiology. It's the whole shebang. It's everything. It's politics. It's culture. It's moral philosophy. And this is where SFI needs to play a role. Can I finish up with just one quick thing, because I want to get to phase transitions quickly. I want to talk about growth. If you take all this theory, growth for biology, it stops. For superlinear scaling coming out of social networks, the kind of thing we saw, then you have faster than exponential growth, which is what we see, but built into the theory is something called a singularity, and that singularity leads to a collapse. And the way we avoid that collapse is recognizing that we have done this in terms of a given paradigm, and we need to reinvent ourselves in order to avoid collapse, and we need to do it faster and faster. That's what the whole, and all of this is driven by the positive feedback mechanisms within social networks. And so, and here's the data to support it. I don't have time to go into it, but here's the point, pardon me, that you need to innovate faster and faster. You need to reinvent yourself faster and faster. You need to have new paradigms faster and faster. And this is an example of something that is dogged our life, and that is the life is inevitably and inextricably getting faster, driven by social networks, and we need to adapt faster and faster. And the problem is we have the same biology and brain that we always had. And it is remarkable how amazingly well we have adapted. And the question is there, in fact, a limit to that? And in fact, in that sense, in terms of this kind of Sisyphean image, is any of this sustainable? And I will finish up with one quote, whoops, famous quote by von Neumann, made in about 1954. The ever-accelerating progress of technology gives the appearance of approaching some essential singularity in the history of the race beyond which human affairs, as we know them, could not continue. And that's the challenge we have. I don't agree with von Neumann. I do agree that we have a tremendous threat, but we need to change something drastically, revolutionarily, I think, in order to combat this. So I'm sorry I went on a little longer than I intended, so thank you for listening. And I hope that is some compliment to the many things that have been said in the last day and a half.
Thank you, Geoffrey. Thank you very much.